Hello guys, so apologies, I assumed incorrectly you were finishing up calculus, so you done integration, so I'm going to do just a quick video because I think you'll be fine with it, and we'll meet up next week at a given time to do a live class, just to get you away with some of these stuff. So a bit of an intro to integration, obviously overlapping with your maths course. So in a nutshell, integration is the opposite, as you probably know by now, of differentiation. So before I try it, you maybe pause the video and see if you can put something in the question mark there. So if I've differentiated this and I've got 3x squared, what would go up there? Okay, pause the video and try it. Okay, solution, and you've unpaused it now, so the solution would be x cubed, right? 3 down, take away the 1, take away the 3. So, however, with integration, I could have a number here, I'd still end up with the same thing, wouldn't I? So when we integrate, we add in what we call a constant. It could be any number there that would disappear if we differentiate. Okay. In your tables, I mean, you have to cancel out that 3, so we have to, in the tables, it's something like this. So n plus 1 all over n plus 1. Right. So we add 1 to the power and we divide by the same amount. Okay. So that becomes 3x cubed divided by 3, they cancel, okay, plus c. And quite simply, that's it. Obviously, it gets a bit more difficult when we look at trigonometric and logs, which we're going to do. A large part of this is in the tables, therefore it's not necessarily a memorizing job. Page 26 gives you what was shown to you. A lot of it is shown to you on page 207 of the book, right? Focus please, camera. So you may go into a bit more detail of this in your maths course, but ultimately you just need to know that when you integrate these, you get to here, okay? I don't think you need to prove it in the maths course, but you might get into a bit more detail. These are all on that page. Okay, important information, constants of integration is omitted, alright, and I'll explain that in a second. So this one doesn't have plus c for a reason, okay, plus c, I'll explain why in a second. On your maths course, ultimately, integration can be used to find the area underneath the curve. Okay, so if I've got a say an inverse quadratic curve there, and I want to find out, and that is, okay, that's the function, and I want to find out the area between two values, okay, of x, and say the values of x are 3 and 7, okay. If I integrate this, I'd notate it like this, 7 and 3, okay? This is called a definite integral. When there's no numbers there, we call the numbers limits, okay? So the limit is from 7, between 7 and 3. We don't need to know the area underneath 3. It doesn't really come up that much on the applied maths course, it's just application for you. If there's no numbers, we call it indefinite. Excuse my spelling there, doesn't look right. Indefinite. Okay. Here we have a constant at the end. Here we don't have a constant at the end. Alright, so let me do an example with you. I picked one there, 1 second. So say if I'm integrating this. Okay, the first thing I do is multiply out so I can integrate each term. Okay? Because then what we do is, come on camera, behave please. Oh no, you've got enough to be thinking about other than an unfocused camera. Because we all need to focus now. Come on camera. Sorry guys, 1 second. Right, that's better. So then we can integrate each term. That makes sense. That's actually the same as we had before. So we add 1 to get x cubed, divide by 3. So the 3's cancel out, okay? We add 1, x to the power of 4, divided by 4. Because there are no limits, we add in the constant. Okay? If I gave you some limits now, if I did the same thing with a limit of 1 and let's say 0, we'd do the same thing. We'd notate it with square brackets. So when we differentiate, we do not have the constant and put the limits here. And what we do is, this is where it works into the area underneath the curve. We put the value of 1 in for x, and we take away then when we put the value of 0 in for x. So it would look something like this. I know the second part is equal to 0, but I was trying to emphasize it for your own workings, right? So we put 1 in for x here, and then we take the lower value away, right? So we do get a definite answer, definite integral for this one. 1 take away a quarter, so 3/4, because this is 0. Alright, so that's the difference between definite integrals and indefinite integrals. I'm not going to say anything else because you can see most of the stuff from the tables, and it's just about you getting exposure. So exposure to these to get used to how they're integrated. I do imagine we'll have to do some of them, but give the work I gave you a go, please guys, after watching this video. Okay, thanks.